This is one of those questions where, like, if you are terrible at math, you'll do something really easy and obvious and get this right. Or if you're really good at math, you'll do a ton of work to try to prove an answer that is the exact same thing, and you'll still get it right, but for probably more effort than is necessary. So let me kind of give you the dumb version first, right? So most people are going to read this or see your graph. The graph of y equals f of x is shown, where f of x is equal to ab to the x plus c, where a, b, and c are constants, meaning they're just numbers we don't know. For how many values of x does f of x equal 0? Well, that's the one part you got to understand, right? They're basically saying, when does y equal 0, right? F of x is y. So they're asking, where does this thing cross the x-axis, right? So what are the x-intercepts of this thing? How many are there? Well, this isn't a parabola, so I can't really use something like the discriminant to think about that. That might be a different kind of topic. But if I just look at the graph, well, it doesn't cross the x-axis, right? I mean, it's all the way down there in the kind of bottom left, right? So it just doesn't cross it. So the dumb person, and no offense if this is what you did, because honestly, this is probably what I would do as well, would just be looking at this and be like, well, there's no x-intercept, so the answer is 0. And that's the right answer. Because if you thought about it more, you might be able to get a fuller picture of what's happening. But the main event is right here on this version of the graph, right? So the danger, if we understand math more conceptually, what we have to worry about is that this is an odd equation type, and maybe it's doing things that are hard to predict, right? We're getting just a snapshot of this f of x equation, right? We're getting just the -10 to 10 range of x values. But maybe it's doing other things at -11, -12, -100, right? Or positive, 500, right? Maybe this thing comes back up and shoots back up and hits the x-axis somewhere, right? And the SAT classifies this as a difficult question. So in theory, if this were on a test, a practice test, it would be somewhere near the end of the practice test where you would expect there to be hard questions. And so just looking at a graph and going like, yeah, it doesn't cross the x-axis feels way too easy for something that is supposed to be hard. But if you saw this question in the question bank and read the College Board's explanation, you can see why they think it's a hard question. Is there's a lot of complicated math that they're using to justify the answer. But you don't need to use that complicated thinking to justify your answer. That's what they do, right? So they're seeing it as hard because it's technically a hard concept. It's a hard equation. It has certain properties that are hard to identify, but you don't need to do any of that work to actually just look at it and be like, yeah, the answer's D. But I'll try to give you my best sense of how we really do know that nothing weird is happening off screen, right? Nothing weird is happening at the ends of this graph. Essentially, you could create a custom regression based on the points we have. It's not perfect, but you can see what I did, right? I took the most obvious points. It looks like the thing goes through 0, -8, so that's there. It also kind of looks like 1, -10. And then if I see, there's a lot of points that have a y coordinate of -7, right? Because it seems to be leveling off at that point, right? But if you understand math at a higher level, you understand that what's happening is it's approaching -7 and it's getting closer and closer and closer, but it never actually gets there, right? So it's getting really close to like, -7.0000001, but it's never getting all the way there, right? It's a limit. But I didn't care about that because I have, to do something, right? So when I plugged in my -7 point, I said -10, -7, just to kind of have the limit of the graph essentially as my limit. So I know this doesn't work, and then, or it doesn't work in a very technical sense, but it works good enough because now it graphs something that looks basically like what they drew. And I can see the custom regression that I built here. We have y1, that tilde means we're doing a regression. AB to the x1 plus c. The x1 and the y1 is telling it go to the points that I just put in the table. I have a whole lesson on the custom regression, so you should check that out. And then you can see here that it's giving me values of a, b, and c that are probably slightly off of what they actually are because I'm also technically estimating at the very least that last point, the -10, -7. So you can see A probably -1, but they've got it as -1.00002, right? B is pretty much 3. C is pretty much -7. So they're more precise than I am, basically. But it gives us a good sense of this thing. And I think then we can see, all right, well, what happens, right, as we go further off of the graph, right? So if I were to go all the way to the right, I can see this thing seems to be going down, right? Does it ever come back up? No, look, it's going very far down, right? We're at 500 and this thing is still plummeting, right? So I don't think it's going to come back. In the same way, I can kind of look at the value here, which is harder because as I zoom out, the -7 starts to blend in with the x-axis. But already at -200, we can see that this line is still pretty flat. It's not going up. It's not getting there. And so I can zoom this way instead and just kind of scroll. And I realize the black line that is our graph, our f of x, is never touching the line that's just above it, which is the x-axis, right? And that's what we're basically asking is where does it cross the x-axis? So already at -3,500, it still hasn't touched it. So I think this would be definitive proof that there are 0 x-intercepts. But I just don't think that this work is really worth it. I think, again, the dumb person gets this exact answer without doing all that extra work, just looking at it and just being like, yeah, it doesn't cross the x-axis. However, you can't be too dumb because I do think some of you are going to pick C, which is the trap, because you get confused between x and y intercepts and you forget what function notation means. And for some reason, you see this as like, oh, how many times does it cross the y-axis, right? How many y-intercepts are there? And of course, there's one y-intercept right there, but that's not what they're asking. So that level of not understanding is too far, right? You have to know the difference between x and y intercepts. You have to know the difference between x and y coordinates. And basically, a lot of times they're phrasing it in ways to try to deceive you. And I think that that's why they said for how many values of x does f of x equals 0, is they know that function notation is just a little bit more advanced than if they had said for how many values of x does y equal 0. I think if they had phrased as y equals 0, some people still would pick C, but fewer of them. What do you think? Is there anything I'm missing here? I mean, again, I really don't think you have to do much work to get this, but this would certainly make me nervous if I saw it during a test because I would want to check what's going on off screen because it just feels too good to be true that you just look at the graph, there's no x-intercepts, and that's the actual answer. It feels like a trap, but it's not. And sometimes it happens, but I guess it pays a little bit to be at least a little nervous so that way you don't fall for stuff and when there actually is a potential trap.